All right. Let's go ahead and start. Did you guys have any questions from the previous lecture?
I couldn't find the book, but I did find it already.
Okay, good. So you guys watched the lecture that I posted for homework 1?
The video, right? The Zoom video?
Yeah.
Yes.
Okay, did you guys have any questions from that before we start the new lesson today? Any questions from that previous lecture?
No.
All right. Naomi, can you hear me?
Yes.
All right, any questions from previous lecture?
No.
All right, let's go ahead and get started with today. So today we're going to continue with the fractions. So last time we learned what fractions are, the concept of fractions. We talked about simplifying fractions, mixed numbers, and also we learned multiplication and division of fractions. So the second part of that unit, R1, is addition and subtraction of fractions. So first, we need to know that when you add fractions, when adding fractions, first have to have the same denominator, what we call the least common denominator. Okay, the least common denominator, or we refer to it also as the LCD, the least common denominator. What that means is when you add two fractions, for example, 2/3, and you want to add that to 1/3 or 1/3. So whenever you add fractions or subtract them, you need to have the same denominator. If the denominator here is not the same, we can't add the fractions. So we check for the denominator, it's the same, that's good, we keep it the same. Okay, we don't add them, it just stays the same. We add.
So we have to add the 2 plus 1?
That's right, exactly. We add the numerators or we subtract them depending on the operation. So 2 plus 1. That's the first rule of adding fractions. The denominator has to be the same. After that, you simplify. And then after you add, you continue simplifying if possible. 3/3 will be?
1.
Just 1, exactly. Okay, so you have to have the least common denominator when adding or subtracting fractions. Other than that, you can't add, okay? Do not make this mistake. A lot of people, they see make this mistake. Let's say this plus 5/7. You just think, oh, it's convenient. I'm just going to add the tops, add the bottoms, like this. And that's very wrong. It does not work that way, okay? So do not do that. If you don't have a common denominator, you will have to find one. We're going to see how to do that in a minute. But before that, let's do an example with subtraction. Say 5/4 minus 1/4, for instance. Can we subtract these two right away? Can we subtract these two fractions right away?
Yes, the denominator will stay the same, and for the top, it should be 4, because 5 minus 1 equals 4.
Exactly, so the denominator is the same. That means we can go ahead and subtract, stay the same. We subtract the tops, 5, take away 1, that's 4/4, which is obviously 1, okay? So that's basically the key here when you add or subtract fractions. Okay, so you gotta have the least common denominator. You have to have the same.
I have a question. You see that we don't have 3/2. We don't have the same so we have to multiply for that one.
In that case, that's right. We need to find the common denominator. Okay, let's do that problem now. So let's say finding the LCD. So let's go back to this specific problem. So 3 over 2 plus 5 over 7. Obviously, we can't add right away because the denominator is the same. So we need to find a common denominator. There are different ways to find the denominator. Some of you can see it right away. For example, what is the common denominator for 2 and 7? In other words, what's the number that 2 and 7 can go into? The least number.
2.
Not 2, because 7 doesn't go into 2. A number that both of these can go into, can fit into evenly, an even number of times. What number 2 and 7 can go into evenly? Or in other words, what's the common denominator for 2 and 7? Or the common multiple? All right, let's see how to figure that out. So what you want to do is you want to take both denominators, 2 and 7, and you basically just do multiples of both. Just do multiples of both until you find a common denominator or a common multiple. Okay, let's start with 2. What is the first multiple of 2? The first multiple of 2, I mean, if you add 2 to 2, you get 4. The next one?
Be 6.
6, then?
8.
Right?
10.
12,
12.
14,
14.
and so on. So these we'll call them multiples. Okay, you just keep adding 2. Then you go to the other denominator and you do the same thing until you find a common number. What is the first multiple of 7?
It'll be 14.
That's right. So we already see we have a common number, so we don't need to continue. That's what we call a common denominator or a common multiple. Okay, no need to continue here with 21, 28, and so on. But if you see a common number, you stop. That would be the least, okay, the least common denominator or multiple. That's probably the easiest way to find the LCD. If you can't see it right away, you can always do multiple. Doesn't matter how many denominators you have. You could have 3 fractions. You do the same thing. You add the third denominator and you just do multiples until you find a common multiple. Okay, so this is what we call common multiple, or LCD equals 14. All right, so now that you find that LCD, let's go back to our fraction. Let's write it over again. Once you find your LCD, what you need to do is we're going to turn these into new fractions, but instead of 2 and 7, we'll have 14 as a common denominator. You want to end up with something like this with the same denominator in order to add these 2 fractions. All right, so basically what you do is you draw 2 new fractions. So both of them should have 14. This common denominator, so both of them will have the same denominator. And we have to change this accordingly. You cannot just turn this into 14 and write the tops here. We have to change this into what we call equivalent fractions. So these 2 will turn into new fractions with equivalent with the denominator 14. So let's see how to do that. Start with the first one. So you turned 2 into 14. How do you turn 2 into 14? You times it by?
7.
By 7, right? Times 7. And here you times by?
7.
Also by 7, that's right? Whatever you times top and bottom by the same thing, that's how you get an equivalent fraction. So this turns into 2 times 7, which is 14, and 3 times 7, which is 21. So this fraction turns into a new fraction, what we call an equivalent. Okay, this is what we call an equivalent fractions. 3 over 2 and 21 over 14 are called equivalent. Then we're going to go to the other one. I'm going to do basically the same thing. How do you turn 7 into 14? Or how many times does 7 go into 14?
2.
That's right, 2. Because 7 times 2 is 14. And here we multiply by?
2.
2.
Also by 2. That's right.
Minus 10 over 14.
Exactly. So this fraction turned into a new fraction, equivalent one. So we changed the top and the bottom proportionally. Okay, we kept the ratio the same. 3/2 is the same as 21/14. Same thing with this fraction, it's the same as this. The numbers are different, but the ratios are the same. So if you now that we have a common denominator, what do we do next? We can go ahead and add, right? Because we have an LCD, the least common denominator. So what goes in the denominator now?
So it's gonna be 31/14.
31/14. So the denominator stays the same. Once you make it the same, stays the same. You add the tops, that would be 31. And always try to simplify your fraction as much as possible. Is there a number that can go into 31/14? We can't simplify it because this is a prime number. Nothing goes into 31 other than 1 on 31. Therefore, there is nothing to cancel. What kind of fraction is this, by the way? What type of fraction? When we talk about proper and improper, what kind of fraction is it?
This would be an improper fraction.
That's right. Why?
Because the numerator is higher than the denominator.
Exactly. So this is the new proper. We can write this as a mixed number. So how do you do that? 14 into 31. How many times does 14 go into 31? 14 on 14, that's 28, right? So that will be, how many times is that? 14 into 31 is twice, because 14 on 14 is 28, so that's twice. You bring over the same denominator. Okay, if 14 goes into 31 twice, which is 28, what's the remainder from here?
3.
3. Very good. So that's the mixed number. That's the improper fraction. Okay, so that's how you find LCD. Let's do another example. Let's say, let's do one with the subtraction this time. Let's say 4 over, let's say maybe 6 minus 1/4. Okay, or let's make this a 5 instead, so we don't have to be simplified. So let's make it a 5. All right, so obviously we can't subtract right away because the denominator is the same. We need to find an LCD. What is the LCD? What's the common denominator for 6 and 4? In other words, a number that both of these can go into, or a multiple of 6 and 4.
It'll be 12.
It will be 12. 12 is the least. Okay, it's not always this times this. Although 6 times 4 is 24, it's also a common denominator, but it's not the least. It's not the least. That's what the L is for. So always try to find the least. It will make the calculation faster and easier with smaller numbers. If you can't see that it's 12, here's how we do it again. We're going to do the multiples. Take the first denominator, take the second one, and basically do multiples of them. What's the first multiple of 6? First multiple of 6 is 12. Next
12.
one. Next one is
16. I mean 18.
18. Then
18.
20.
24.
24, and so on. Okay, let's start with the 4. See if we can get a common denominator like one of these. If not, we're going to continue here and here until we find the least common denominator. 4 into, what's the first multiple of 4? That's 8. Then
12.
12.
12. Do we need to continue?
No.
No.
No. So what's the LCD here?
12.
12.
Exactly. So 12 is a common number. So you stop right here. So the LCD equals 12. Okay, now that we found the LCD, what do we do with it?
Now you gotta convert 5 times 2.
5 times 2. So basically, we're going to turn these two fractions into new ones with
6 times 2.
both of them should have 12. 6 times 2, that's right. So
Yeah, 12.
you write the new fractions. These will become new fractions with the same denominator. Now, how do you get from 6 to 2? We times by, you said by 2, right?
By
On the
2,
top.
yeah.
The top also by 2. So this one is equivalent to this fraction, 6 times 2 is 12, 5 times 2, that's 10. What about the next one?
So
By 3.
4, yeah, by 3.
That's right,
Times
by
3.
3, also by 3. So you get your fraction here,
3.
right, and 12. These are equivalent again. And now we can go ahead and subtract these two. So the denominator stays the same, the common denominator. Subtract the top, 10, take away 3, that's 7. Can we reduce this fraction? Can we simplify it?
No.
No, nothing goes into 7 or 12 at the same time other than 1. What kind of fraction is it?
Proper fraction.
Say that again. What type of fraction is it? This one was what again?
A proper fraction.
Improper, and this one is?
Would it be a proper fraction?
That's right, it is proper
It's not
because
a
the top,
fraction.
that's right, it's proper because the top is smaller than this. So we can't write this as a mixed number. We only write improper fractions as mixed numbers. All right, so all right, so that's basically how you find LCD. Another way, this is another problem here, another example, and I'll show you a different way to find LCD. So this is basically a common, some of you can see it right away using the table of multiplication. So knowing the table of multiplication well makes this a lot easier. You can see the LCD right away. If not, you can do the multiples, or let me show you another method of finding the LCD. So let's say 1 over, let's say 8, or 1 over 8 added to probably, let's say 24, and maybe 7 here. Actually, let's make it smaller. Probably just 1. Okay, just make things simple. You probably already see what the LCD here is, or you can always use multiples. There is a second method to do this that involves factoring these denominators. That's probably, especially if the numbers here are not common or not as simple as these, you may want to use the method of factoring and the prime numbers. Probably the most effective and probably the fastest way as well to find LCD. So this is how this works. You take both denominators and just factor them. You break them down as we did in the last lecture, factoring. So we take 8. Two numbers that multiply to 8 are?
4 and 2.
That's right, 4 and 2. Then you continue breaking them down as much as possible. Can we break down the 4?
Yes, you could do 2 times 2.
2 and 2. You can't break down the 2, just break it down. So these are called prime factors of 8. 2 times 2 times 2. Then you take the other denominator. You do the same thing. Break it down as much as possible. So 24, we can start with 8 and 3. Then 8 again. As we saw here, 8 is 2, 2 and 2. 3 2s. Bring down the 3. So prime factors of 24 are 2, 2, 2, and 3. Prime factor of 8 are these. So here's how we find the LCD. Just take enough numbers to make both. So basically, go to the number with the most, take one of these, either one. Take one of these and write all the digits. Usually the one with the most digits, just write it down. So we're gonna write all this down. So 24 is 2 times 2 times 2 times 3. Now, so to make 24, we need 2, 2, 2, and 3. To make 8, we need 2, 2, and 2. We already have them here, okay? We already have those here. So we don't need to add any digits from here. So this makes up 24. And these 3 make up 8. That means this number here contains both denominators. If something was missing here, let's say for some reason this number had another number here, let's say, for example, 7. So to make whatever number this is, 2 times 2 times 2, that's what, 8 times 7, that's 56. If this was 56, for example, so to make this number, what is missing here in these digits in order to make this number here, 56? So to make this number, we need a 2, and a 2. We already have them here. What is missing to make this 56? We need to add, what digit is missing here to make this number? The 7, right? So to make, for example, this 56, we need 2, 2 and 2, and the 7. Since we already have those three, the 2's here, we just need a 7. That would be it. This will be the LCD for 56 and 24. Just a hypothetical situation. Here we have 8, so let's go back to 8. Okay, for our example, if you multiply these, we get 24. So that's the LCD. Again, this is a second way to do it, in addition to doing multiples, because sometimes this takes a long time and you may have to do many multiples to find LCD. This can be efficient and quick when you factor and you take just enough digits to make both numbers. So again, to make 24, we need 2, 2, 2, and 3. To make 8, we need 2, 2, and 2. We already have them here. No need to add any extras. And you multiply all these numbers to get 24. All right, what do you do now with the LCD after you find it? So these two fractions will turn into 24. 24.
You gotta multiply by 3.
That's right, multiply it by 3, here by 3, and over here by, to turn it 24 into 24, it times it by
1.
By 1, and also by 1. And the 6, so it will be 3 and 1. That's 4 over 24. Can we reduce this fraction? Can we reduce it? What goes into 24 and 4, the highest number? What goes into 4 and 24? Could be 2 or
1.
or something higher.
6.
No, into both of them. They both share it. What do they share? They share 2 or what? Or what goes 4, right? 4 goes into 4. How many times? How many times does 4 go into 4?
1 time.
1 time. And 4 into 24. How many times does 4 go into 24?
5 times. Wait, yeah.
Not 5 times. Close.
6.
6. That's right. 6.
6, yeah, sorry.
Okay. You need to know your multiplication tables because that makes things a lot easier when you deal with fractions. Okay. So it makes it easy to simplify here, and also makes it very easy to see the LCD right away. So when you see the LCD right away, you don't even have to do this stuff. You don't have to do this. Most of the time, you'll just say 2 and 7. Oh, the LCD is 14. Okay, so knowing the multiplication table actually helps you subconsciously find the LCD and simplify fractions. Okay, so this fraction is just 1/6. It's a proper fraction. We reduced it. So that's basically how you find LCD to add and subtract fractions. Okay, does that make sense to everybody at this point?
Yes.
Any questions?
Yes.
All right, so now let's see how to add and subtract mixed numbers. Quite similar, just need to do a little conversion in the beginning. So this one, again, that's what we call a mixed number. When you have an improper fraction, we can write it as a mixed number, or we can go backwards, turn a mixed number into an improper fraction. So let's do that. So adding and subtracting mixed numbers. Mixed numbers. Okay, so start with a simple one. 1 over, let's say, 3 plus 1 and 2 fifths. So we're adding two numbers here. They're both mixed numbers. What do you think we need to do here in order to add these two mixed numbers?
We multiply 2 and 3.
That's right. So multiply 2 and 3 and add 1. So we need to convert these mixed
Right.
numbers into fractions. We need to make them fractions like this. Once we turn them into fractions, we can go ahead and do the same thing here and find the LCD and add and subtract. So convert into mixed numbers into fractions. Start with the first one. So to convert, you times this way and add this. 2 times 3, 6 plus 1 is 7.
Mhm.
Over the denominator stays
Three.
the same. So this fraction or this mixed number is basically the same as this, just written in different forms. What about the next one?
The next one will be 7 over 5.
It will be, that's right, 1 times 5, that's 5, plus 2, that's 7, over 5. That's the first step. Always convert your fractions. Some people like to add the whole numbers together and the fractions together. You can do that if you feel comfortable with it. But to be consistent, I would suggest you turn all your mixed numbers to fractions first. Whether you're adding, subtracting, multiplying, or dividing, always turn mixed numbers into fractions. Once you turn them into fractions, they make more sense. They're probably easier to deal with following this. All right, what is the LCD for, this actually should be a 3, okay? 3 and not a 2. Nobody corrected me. Otherwise, you guys, you would have won some extra credit stuff, right? So 3, I made a mistake here. 3 should be 3 here, not 2. Now, can someone tell us right away what's the LCD? What is the common denominator for 3 and 5? Anyone? What's a number that 3 and 5 can go into? Or what's a common multiple for 3 and 5?
15.
Very good, that's 15, okay? You can do it the same way we did here, the multiples. Sometimes you can just multiply them if both are prime. If both of these are prime, that means you can't break them down. If they're both prime, then the common denominator is just the product of the two. Here, the product of the two is not the LCD. The product of the two is 24, which is also a common denominator, but it's not the least. Why? Because these are not prime. 4 is not prime. We can break it down into 2 and 2. 6 is not prime. We can break it down into 3 and 2. Only if both of them are prime, you can just multiply them to get the LCD. So in this case, they're both prime. So we can just say the LCD is 15. So we're going to turn both of these into 15. 15, 15. Okay, how do you turn, so to turn 3 into 15, we times it by 5 on the top.
5 times.
5. What about this one? By turn into 15.
3.
By 3 and 3. So that's 35.
35.
Right?
And 21.
21.
Very good. Over the denominator remains the same. And we add these two. What's 35 plus 21? 50.
56.
56. 56. Now, do you think we can reduce this by something? First of all, that's an improper fraction. Can we simplify it into something? What goes into 15? 15 is made with 3 and 5. Can 3 and 5 go into 5 and 6? 56? 3 and 5 do not go into 5 and 6, so there's nothing to cancel. Okay, only 3 and 5 go here. They don't go into this, so they can't be canceled. But we can turn this into a mixed number. Always turn your answers into mixed numbers if they are improper, especially if you start with mixed numbers in the beginning. How many times is 15 going to 56?
3.
3 times. 15 and 15 is 30 plus 15 would be
56.
45, right? 3 15s here. We can't add another one. If you add another one, it would be 60, it would be over. So we can say, so that's 3 times. Or you can do additions on the side. Just keep adding 15. 15 plus 15 plus 15 is 45. If you add another 15, it will be over. So it's not enough. So 15 goes into 56 3 times. You do a letter line in the middle of the number 3, not the base. Letter fraction here. What's the denominator? What goes here?
15.
The 15. So the denominator stays the same. Now, if 15 goes into 56 3 times, that's 45. How much is left? How many?
11.
How much?
11.
11, that's right. You can get that 11 by subtracting. So 15 from 11, from 56 will be 11. So that's the final answer as a mixed number, 3 and 11 15ths, okay? Again, especially if you start with mixed numbers, make sure you present your answer as a mixed number if the final answer is if it's an improper fraction. When you take tests in the computer, for example, if they give you an operation like this, the options to choose from will be in this form. It won't be this one. So you need to know how to turn this into a mixed number and vice versa, how to go back. Even if you did this on paper and it's correct, but in the computer, it will most likely give you options like this to choose from. You will not see this mixed number, this improper fraction. Okay,
Can they give you the fraction like to convert it into decimal or no?
Most likely. We sometimes the answer could be a decimal. That's our the subject of our next class. We're going to talk in detail about how to turn this into decimals.
I have a question, teacher.
Sure.
We have to come back because the time is running out. We only have 6 minutes.
Okay, so we're going to continue. We're going to finish this one. We only have one more problem, and we're done with this lecture. Then we're going to continue with this on the on Blackboard, on the discussion board.
Oh, okay.
Okay, we're going to do a few things there. We're going to go to, I'll show you the homework folder, the lesson plan. I'll show you we're going to do something on the discussion board. Okay, so right after we disconnect from here, continue on the discussion board. But let's do one more example here, and we're good to go. So let's say you have 2 minus 1 and 2 fifths. So we're subtracting 2 different numbers. One of them is, what kind of number is 2?
Prime number.
That's a whole number or an integer minus a mixed number. They're 2 different numbers, so we need to make them in the same form. What is that form we're going to turn this into? What form are we going to convert these 2 into in order to add them, to subtract them? We're going to turn them into, basically like we did here, we're going to turn them into fractions. We know how to turn this one into a fraction. How do you turn 2 into a fraction?
Become 2 over 1.
That's right, just 2 over 1. Any whole number or integer can be turned into fraction simply by putting 1 underneath. Then this one again will be 1 times 5 plus 2, 7 over 5. Again, always convert your numbers into into fractions, then add and subtract. What's the LCD for 1 and 5?
5.
5, that's right. They're both prime. We can't break down the 1. I mean, 1 is not prime, but we can break it down. We can't break down the 5, so you can just multiply them to get the LCD. 1 times 5 is 5, so we're gonna put 5 here. How do you turn 1 into 5? You times it by?
By 5.
By 5 on the top.
And then 2 times 5, you get 10.
And over here, to turn 5 into 5, you turn times it by?
And then for 5 will be 5 times 1.
By 1, that's right, by 1, it won't change. So we have 10 here, we have 7, That's 3 out of 5. Do we need to reduce it?
No.
No. What kind of fraction is it?
Improper.
That's right.
Proper.
It's a
Proper.
proper fraction, and that's basically the final answer. Okay, and that's basically how you add and subtract mixed numbers, fractions, whole numbers, anything, whatever you have, basically works out that way. Let's say we can do one more example here. Probably another subtraction with mixed numbers. So let's say 1 and 3 and 1. 3 and 1/2 minus 2 and maybe 3/5. Well, actually, we did this one already. Let's do maybe 7 here or 8. Doesn't matter. Okay, so let me try to do this one again quickly. So first, we're going to need to convert this into fractions. Convert both of these into fractions. So 3 times 2 plus 1, that's 7 over 2 minus 2 times 7, that's 14, plus 3 will be 17, and bring over the same denominator. What's the LCD again for this? We already saw it. LCD will be for 2 and 7. They're both prime. We can just multiply them. So the LCD will be be 14. You can do the multiples. That's how we're going to times this by 7. By 7, that's 49. Then it times this by 2. By 2 will be 34. Okay, so as you can see, we have the same LCD denominator. We can put it in the denominator, then subtract. What's 49 take away 34? It would be 15, right? What kind of fraction is it?
Improper.
That's improper. How many times does 14 go into 15?
1 time.
1 time. And what's left? What's the remainder?
1.
Exactly, 1. That's basically how you add and subtract fractions and mixed numbers, and how to find LCD. So 1 and 1/14 is the final answer. Okay, you guys got everything here?
Yes.
Okay, any questions? Anybody have a question about this problem or anything? All right then, so let's take over or take this or go over the few things on Blackboard, okay? Join the discussion board, okay? We're gonna say a few things there. Make sure you engage there, post something. Again, that's important for attendance, for participation. And also, you'll see the lesson plan there, and I'll add this lecture later. I'm gonna edit it. I'm gonna add it to next to homework 1. This is part of homework 1. All right, I'll see you guys in the discussion board in a few seconds, okay?
Okay.
All right, guys, thank you for coming, and I'll see you on the discussion board.
Thank you. Good.